When we talk about system of ODE, first we look at the general form, how it is written, and then we look at the normal form. And then there are two methods of solving these system of ODE. So we look at those as well. Okay. So the first is the general form. Okay, we will be looking at linear system of ODE, meaning the derivative will be of first order and then there'll be no multiplication between the dependent variable and its derivatives. Okay, so that's what we will be doing here. We will be looking at the linear system at over here. Okay. So the general form of any linear system of ODE is going to be something like this. Now these A1, A2, A3, A4 are strictly going to be functions of t only. And when we say system, it's going to be more than one equation. Okay. So this equation star is called a system of ODE. This is the general form of linear system of ODE. Now, if I want to convert it into quadratic, I may have something, more complex, like I will have A1t d square x by dt square, A2t d square y by dt square. Then you'll have A3t with d square, not d square, dx by dt. Then you'll have A4 with dy by dt. Then A5 with x and A6 with y. And again equal to f1 of t and so on. Okay. Again, you can have the same with three dependent variables. Here, understand there are two dependent variables. There is x and y, which are dependent variables. T is the independent variable. Okay. So, yes, you can have more than two dependent variables also. So, if I have like three dependent variables, okay, this again will have one more system here, like B1, B2, B3, B4, B5, B6, and so on. So, if we talk about three dependent variables and only linear, it will be something like this. Now we'll have one more dependent variable, say z. Okay, A3 is again a function of t. Okay, and like that you will have a total of three equations here. You'll have one with B1, the other one with C1. I hope you're understanding this, students. Any difficulties?
What does A1, B1, and C1 stands for?
Sorry, can you be a little louder?
Yeah, what does this A1, B1, and C1 stands for? They are
A1,
more
B1,
like,
C1 could be any functions of t. So let's take example here. Let's take examples here. So if I have, say, t square dx by dt minus 2t dy by dt plus say 2x minus 3y is equal to say t cube. First equation. Then I can have another equation as just dx by dt plus t times dy by dt. This is t minus say e raised to x plus say t times y equal to e raised to t. Okay. So now over here, in this case, this is your A1. which is a function of t. This is your a2. This 2 is your a3, the constant. The minus 3 is your a4. This is a function of t, which is on the right hand side, and so on. I hope this is clear now. Is this okay?
Yes.
Fine. So this was an example. Now, general form is little difficult to use to solve our equations, and hence we come to something called as a normal form. Okay, we come to something called as a normal form, which is used to solve our equations. So what is the normal form of our equations? We convert the equations into dx by dt. Okay, if we are working only in two variables, say x and y, I convert it into a1 of tx plus b1 of ty plus f1 of t, and dy by dt is equal to say a2 of tx, b2 of ty plus f2 of t. Now, over here, if f1 of t is equal to f2 of t is equal to 0 for all t in the interval where we are working, then this system star over here is called autonomous. Is called autonomous system here. Okay, and if any of these, otherwise you can say, so even if one of them is not equal to 0, otherwise it is called non-autonomous. Okay, so this is what an autonomous system is and non-autonomous system is. Our main target is going to be to solve the system where these A1, A2, B1, B2, all of these are constants. Okay, we will be learning the methods where we will be working on constants over here, and F1, F2 will be zeros, where F1 and F2 will be zeros. So let's learn the different methods here. So our target is going to be to solve autonomous systems of linear ODE with constant coefficients. We are going to learn to solve the autonomous system with linear coefficient. The first method which we need to know is called the operator method. A very simple method. It is nothing but your basic algebra which you have learned in say class 9th and 10th. Okay. So to explain this particular method, I'm going to use say an example over here. So let's use an example. This is say question number 1. Okay. The question says solve dx by dt, which is equal to 2x plus 3y, and dy by dt, which is equal to 7x minus 5y. Okay. So we are expected to solve it using operator method. You can observe this is already given in the normal form. Normal form is the easiest to solve any given set of equations. Okay, we can do it faster. So let's use the operator method and let's learn how to do this. Okay. So let's begin. What we're going to do here is we'll let d by dt be denoted by capital D, which is the differential operator. So the first equation is now dx equal to 2x plus 3y. And the second equation is dy equal to 7x minus 5y. I hope this step is clear with everyone. Yes, students?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now, we bring all the coefficients on the, or all the terms on the left-hand side. So I'll have dx minus 2x minus 3y is equal to 0. And over here, I can bring everything on the right because I want the x term first. 7x minus 5y minus dy equal to 0. Let me take the x common. So I have the operator d minus 2 working on x minus 3y equal to 0. This is equation number 1. For the second one, I have 7x minus d plus 5 working on y equal to 0. Equation 2. I hope things are clear so far. Because if this is clear, after this we are going to use basic algebra, the normal, solving of two different equations, the equating coefficients method. Okay, so let's use after this. What we are going to do here is we either make the coefficients of x equal or the coefficients of y equal. So if I decide to make the coefficients of y equal, I'll multiply the first equation with d plus 5 and the second equation with 3. So basically you're again operating the operator here. So when I multiply the first equation with d plus 5, I will have d plus 5 operating along with d minus 2 on x minus 3 times d plus 5 operating on y. And on operation with 0, it will give me 0. Then you will have 3 into 7, which is 21x, minus 3 times d plus 5 working on y, and the right hand side is going to give me 0 again. We will subtract the two equations. So when you subtract the two equations, these terms get cancelled. And let's open these brackets. You will have d square plus 3d minus 10 minus 21 operating on x is equal to 0. So this becomes d square plus 3d minus 31 operating on x equal to 0. I hope this is clear with all of you. Any difficulties so far?
No, ma'am.
No, ma'am.
So now here the numbers are a little weird. So just to understand the method, this is a second order differential equation. We'll form the auxiliary equation. So we'll have m square plus 3m minus 31 equal to 0. And the roots will be given by negative 3 plus or minus under root of 9 plus 4 into this is going to give me 124. Okay, divided by 2. So that's negative 3 plus or minus. This is under root 133 divided by 2. So if I call m1 as negative 3 plus root 133 divided by 2 and m2 as negative 3 minus root 133 divided by 2. What happens here is I will get x of t. X of t as c1 e raised to m1t plus c2 e raised to m2t because these are going to be real roots, right? मतलब 133 का जो root आएगा उसमें I नहीं आने वाला है. These are real roots and they are distinct. So we are using that formula here. Okay. Now once you get x of t, we can use equation number 1 to find y of t. How will we do that? Let's see it here. So from equation number 1, I have the operator d minus 2 working on x minus 3y equal to 0. And I can therefore say 3y is equal to d minus 2 operating on x, which is the derivative. The first d will give me the derivative of x and minus 2 will be 2 times x. So when I take the derivative, I'll have c1 m1 e raised to m1t plus c2 m2 e raised to m2t minus 2 times C1 e raised to M1t minus 2 times C2 e raised to M2t. And for taking it as y, I need to multiply this entire thing by 1 by 3. Okay. You can now combine the terms with e raised to M1. So e raised to M1 comes with C1 M1 minus 2 C1 and e raised to M2 is with C2 M2 minus 2 C2. So this is your y of t and this is your x of t. So these two functions x and y together will satisfy or will be the solution of the system of your given linear differential system of equation. I hope the operator method is understood by everyone. Okay, let's take up one more example and then maybe I'll give you one example to try on your own. Okay, so I'll take one example and one more thing to understand over here is that C1 and C2, like here we left it unknown, right? Okay, but if the initial conditions are given, if there are some initial values given, then you will be able to find C1 and C2 also. So that will depend from question to question. Okay, so let's look at question number 2. So now we have something with the initial conditions also. Okay, dx by dt equal to negative x plus y and dy by dt equals to negative y with x of 0 is equal to y of 0 is equal to 1. Come on. How will we start with the question? I'll require steps from you now. Yes, students? How do we start with this particular question?
D by dt equal to D.
Correct. d by dt is equal to d. Okay. Then what happens to the first equation?
dx equal to minus x plus y.
It will become
Y
dx
is equal to minus y
Okay.
plus
So can
plus
I
z.
say
x
d plus
minus
1?
y.
D plus x plus y.
Can I say d plus 1x minus y equal to 0?
Yes.
And second
D
one,
plus y.
correct. Second one does not even have a x term. So I'll just have d plus 1
Y equal to 0.
Okay, so now let's understand here, students. Instead of following the general method here, I can directly solve equation 2. Your equation 2 only has y, right? So
Yes.
auxiliary equation would be m plus 1, which is equal to 0. So m is equal to minus 1. So your y of t would be equal to c1 e raised to minus t. Correct? And let's use the initial condition. Y of 0 is given as 1. So since y of 0 is given to us as 1, so when we substitute t as 0, we will get 1 is equal to c1. E raised to 0 हमारा 1 हो जाएगा. So now you got the correct answer for y of t without any constant as e raised to minus t. Now let's use equation number 1 to find x. So from equation number 1, d plus 1 applied to x is equal to e raised to minus t. It's equal to y, which is equal to minus t, e raised to minus t. Is that correct? Any difficulties? Yes, please.
No, ma'am.
Okay, how will you solve this further? इसको आगे कैसे करोगे? चलो. Anyone? How do you solve this further?
Auxiliary equation is in here.
Okay, there are two methods. One is this is a linear equation also. So you can use the first order linear equation method. Second option is auxiliary equation, and with that you will get complementary function and particular integral. Okay, so आप complementary function लेके particular integral लेके solve कर सकते हो, या फिर you can solve it using the linear method. Okay, to look at the linear method, it is actually given like this: d by dt of x plus x is equal to e raised to minus t. Okay, so you can do it by linear or you can do it by, say, auxiliary. If I do it by auxiliary, what will I get here? I'll get this as m plus 1 is equal to 0. M is again minus 1. So the complementary function will be c1 e raised to minus t. Okay, c1 is already used, so let me use c2. Okay. And particular integral. How will you calculate the particular integral here? 1 upon d plus 1 applied to e raised to minus t. If I use the shortcut method, I have to substitute minus 1 in place of d. So the denominator is becoming 0. In that case, I have to multiply by t here and take the derivative of the denominator, which is 1, and e raised to minus t. So this is t e raised to minus t, which is the particular integral. And my x of t, which is the general solution, will be complementary function plus particular integral, which turns out to be c2 e raised to minus t plus t e raised to minus t. Again, there is an initial condition given to me. They've given us that x of 0 is equal to 1. So let's use that. Since x of 0 is 1, so 1 is equal to c2. All the other terms will become like, here there is t, no? So when we put 0 here, it will become 0. So now x of t is equal to e raised to minus t plus t e raised to minus t. This is your x of t, this is your y of t. So this is your required solution. Any difficulties?
मैम ये पर्टिकुलर सॉल्यूशन कैसे निकाला?
पर्टिकुलर सॉल्यूशन कैसे निकालते हैं? ये आपने लीनियर इक्वेशंस के टी.वाई के इसमें पढ़ा है. ये मैंने शॉर्टकट मेथड अप्लाई किया है. आप शॉर्टकट मेथड अप्लाई करो या फिर आप डायरेक्ट मेथड अप्लाई करो. शॉर्टकट मेथड में ये रूल था आपका कि अगर e रेज टू mx है और नीचे फंक्शन ऑफ d है, तो यू रिप्लेस d विथ m. यू रिप्लेस d विथ m. बट अगर f ऑफ m 0 हो रहा है, so then you multiply by x and 1 by f dash of d you apply to e raised to mx. Again यहाँ पे you will replace d with m. ओके, एंड अगर यहाँ पे f dash 0 नहीं हो रहा है m डालने के बाद, तो यू कैन यूज इट. अदरवाइज वापस x से मल्टीप्लाई करके वापस वही प्रोसेस फॉलो करना. ओके, सो दैट्स व्हाट वी डिड. यहाँ पे हमारे पास e रेज टू माइनस t था, मतलब x की जगह t है यहाँ पे, एंड f ऑफ d की जगह पे d प्लस 1 था. तो यहाँ पे जब d की जगह पे -1, m की वैल्यू -1 है, -1 डालोगे तो ये 0 हो रहा है. तो 0 हो रहा है तो आपको x टाइम्स इसका डेरिवेटिव होगा 1. तो 1 में अगर आप e रेज टू -1 डालोगे, मतलब वहां पे d है ही नहीं, तो कोई क्वेश्चन ही नहीं बनता. तो ये आपका फाइनल आंसर आ जाएगा, पर्टिकुलर इंटीग्रल. दिस मेथड इज फॉर e रेज टू mx का फॉर्म. दिस इज अ शॉर्टकट मेथड टू e रेज टू mx फॉर्म. इज ओके?
यस मैम.
यस प्लीज.
यस मैम.
ओके, सो या, is this question clear? Any difficulty? Let's try a non and autonomous also, means we will have some functions of t also on the right hand side. Let's try those as well. Okay. So again, the main question is going to be solve the system of linear ODE. The system is 2 dx by dt minus 2 dy by dt minus 3x is equal to t. Now you can see there is a function of t, therefore it is non-autonomous. Then again you have 2 dx by dt plus 2 dy by dt plus 3x plus 8y is equal to 2. Okay? So दोनों इक्वेशन में t का टर्म नहीं है, बट किसी एक इक्वेशन में भी अगर t का टर्म आ जाता है इंडिपेंडेंटली, देन इट इज अ नॉन ऑटोनॉमस सिस्टम. ओके, सो अगेन द स्टार्ट इज गोइंग टू बी द सेम. d by dt को कैपिटल D ले लेंगे. सो फर्स्ट इक्वेशन बन जाएगा हमारा 2 कैपिटल D. ओके, 2 times capital D minus 3, this entire thing is applicable to x, and minus 2D is equal to, this is applicable to y. Is this correct? Equation number 1. Equation number 2 will be 2D plus 3 applicable to x and plus 2D plus 8 applied to y equal to 2. Any difficulties? This is okay?
Yes, ma'am.
Okay? इसके बाद
Yes,
क्या
ma'am.
करना है? इसके बाद क्या करना है? इक्वेशन 1 एंड 2 को इक्वल करना है, मतलब कोएफिशिएंट्स इक्वल करने हैं. y के इक्वल करते हैं, उसके ऑपोजिट साइंस है. तो सो यहाँ पे ऑपरेटर 2d plus 8 अप्लाई करेंगे वापस, और यहाँ पे ऑपरेटर 2d अप्लाई करेंगे. सो व्हाट डू आई गेट हियर व्हेन आई अप्लाई 2d plus 8? Already this 2d plus 8 will work on this answer, 2d minus 3 applied to x, and then 2d plus 8 will work on 2d applied to y. Right hand side पे भी this will also be applicable. Okay, 2d plus 8 will be applied to t, and second equation now will become 2d applied to 2d plus 3x plus 2d applied to 2d plus 8y and 2d applied to 2. Okay, now one thing let's understand here, the order of the operators is not important. Like, you're having 2d applied to 2d plus 8, and you also have 2d plus 8 applied to 2d. The order is not important. The answer will exactly be the same in both the cases. You can check it taking any example of a function. ओके, ये आंसर आपको एग्जैक्टली सेम देगा. अगर आपको चाहिए तो यहाँ पे ट्राई कर सकते हैं. इसको हम एक्स स्क्वायर या फिर थोड़ा सा बड़ा पावर लेते हैं, बिकॉज या एक्स क्यूब पे अगर अप्लाई किया, सो ये फर्स्ट वन में इफ आई अप्लाई 2d plus 8 पहले एंड देन 2d बाद में, सो 2d एज इट इज, 2d plus 8 होगा फर्स्ट डेरिवेटिव मल्टीप्लाइड बाई 2, so that is going to be 6x square and 8x cube. Okay, and then when I apply 2d again, so second derivative, that is going to give me 12x. Okay, and into 2 will give me 24x, and this will become 8x cube ka first derivative will be 24x square into 2, so that's 48x square. Okay, now let's see the second one. If I apply to x cube, पहले 2d लगाया अगर, तो 2d plus 8 is as it is. So 2d when applied to x cube is going to give me 3x square into 2, which will give me 6x square. And now if I apply this, it is going to give me 12x into 2, which is 24x, and 8 times 6x square is 48x square. So you can observe these two are exactly the same. I hope you're understanding this. So the order of the operator is not going to matter. Okay, and this is because we are going to now add these two equations. When I add these two equations, these operators will get cancelled, because ये दोनों आपको जो आंसर फाइनल रिजल्ट देंगे वो एग्जैक्टली सेम होगा. Okay, now let's add the other terms. The first term is 4d square minus 60 plus 16d minus 24, and the second one is 4d square plus 6d, and this entire thing is applicable to x. I hope this is okay with everyone. I've just opened the brackets here. And we can see that negative 60 and positive 60 is getting cancelled. I'm left with 8d squared plus 16d minus 24 applicable to x. On the right hand side, we have 2d plus 8 applicable to t. So 2 times the derivative of t. Derivative of t will be 1 because capital D is d by dt. You're taking derivative with respect to t itself. So that will leave us 2 and 8t over as it is. Okay. The right hand side of the second one, we're adding the two equations, right? So the derivative of 2 with respect to t is going to give me 0. So this is what I will have on the right hand side. Is this okay with everyone? Any difficulties? How did we get the left hand side? How did we get the right hand side? Is this clear?
Yes, ma'am.
Okay, everyone?
Yes, ma'am.
Okay, now this is a non-homogeneous second order differential equation. So यहाँ पे again complementary function and particular integral दोनों निकालना होगा. So let's start with both. To calculate that, okay. Also there's a 8 which is common in all the terms on the left hand side. So I can take this 8 common and I can shift it to the right hand side. So I will have something like this. Now this should become 2. Now I have taken 8 common. And this will become 3. And this side if I divide by 8, I will have 1 by 4 plus t. Okay. So now let's find the particular integral and complementary function. For the complementary function, we consider the auxiliary equation, which is m square plus 2m minus 3 equal to 0. What are the roots here? Yes, please. Roots there, please.
M is equal to 1 and M is equal to minus 3.
Perfect. M is equal to minus 3 and M is equal to 1. And if these are the roots, I'll write x of t as c1 e raised to negative 3t plus c2 e raised to t. Okay, this is your complementary function. Okay, how will we find the particular integral in this case? How will we find the particular integral in this case? The particular integral will be found by taking this function on the denominator. That's your, I can split it as d plus 3 into d minus 1. Is that correct? Applicable to 1 by 4 plus t. Now how do you apply it? How do you apply it here?
Partial fraction?
Yeah, you can use the partial fractions method or you can do one at a time also. That is also going to work. Okay, so if I apply the partial fractions method, I'll have 1 upon d plus 3 into d minus 1 is equal to a over d minus 3 b over d plus 1, which will be a times d plus 1. So when I put d is negative 1, we would get minus 4b. So b is equal to negative 1 by 4. And when we put d is 3, we would get a is equal to positive 1 by 4. So now we can write this as 1 by 4 times. Okay, I think I made a mistake. Now this is plus, no? And this was minus. So then, in that case, I'll put plus 1. Okay, this is minus and this is plus. So when I put plus 1, I would get b is positive, and when I put minus 3, I'll get a is negative. Okay, so A is negative and B is positive. Okay, how do you apply it to the functions here? How do you apply it to the functions here? Yes, please. What's the formula for the operator here? You've done this in BSc. This was a part of like differential equations there also, finding the particular integrals. Yes, students. No one yet? Do you know or you don't know? Well, let's not waste time.
No idea, ma'am.
Okay, fine. So, see, one is what you said is partial differential. You can do that way. Okay, while splitting it into partial differential, that is one of the methods of doing it. Second method, when you cannot split it into partial, or means if you don't want to split it into partial, also you can proceed with what we are going to do after this. Okay, so when I have this linear operator, we have already split it into linear operators in the bottom. Okay, so when I split it into linear operator, I would have the first operator, okay, minus 1 by 4 as it is. We leave e raised to minus 3t. This minus 3t is because of the plus 3t here, the opposite sign, okay? You need to take it. And you take the integral of whatever is the first function, say maybe 1 upon 4 plus t into e raised to plus 3t. That's how you will operate the first operator on 1 upon 4 plus t. And how to operate the second one? Again, the same manner. 1 upon 4 e raised to t outside, and inside it will be 1 upon 4 plus t e raised to minus t. Are you getting this? Any difficulties here? Is this fine with everyone?
Yes, ma'am.
Yes, students, did you understand this?
Yes, ma'am.
Okay, so let's work on the integral part and we'll be able to find the answer. So the integration of here is negative 1 upon 4 e raised to minus 3t. We have to apply the UV rule, and the UV rule is, this will be u as it is. Integration of e raised to 3t is e raised to 3t divided by 3. Okay, and then you'll have a minus. Derivative of the first part is going to be 1. And again, if I take the integral, it's going to be divided by 9. This is the first term. Just give me a minute. Someone wants to join. Okay. Yeah. This was the integral of the first part. The second part now. Plus 1 upon 4 e raised to t. Again, the integration, the first part remains the same. The integral of e raised to minus t is e raised to minus t divided by minus 1. Minus the derivative of the first part is again 1, and e raised to minus t divided by minus 1 square. So I'll continue this side. I am left with now minus 1 by 4. Let's push this e raised to minus 3t inside. Okay, so that gives me 1 by 4 plus t only remaining, because e raised to minus 3 and e raised to plus 3t will get cancelled, and I'll be left with 1 by 3. And again, the next term will give me a minus 1 by 9. Plus 1 by 4, again we'll push this e raised to t inside. We will be left with 1 upon 4 plus t with a negative sign because of the minus 1 in the denominator. And the second term leaves us a minus 1. Okay, so let's simplify these values here. This is going to give me minus 1 by 4. First, let me solve the brackets. 1 over 12 plus t over 3 minus 1 by 9. And this is going to give me, okay, let me take the minus sign out. So I again have a minus 1 over 4, or let me put everything in the same bracket so that minus 1 over 4 is everywhere. So I'm now with 1 over 4 plus t plus 1. I have taken the minus sign out, okay? So, yeah, this is minus 1 over 4. All the fractions, I have 1 over 12 minus 1 over 9 plus 1 over 4 and plus 1. The LCM is 36. So I'll have 3 minus 4 plus 9 plus 36. So that's going to give me 48 minus 4. That's going to be 38. Is that correct? Over 36. And again, I do have t terms twice. So that's going to give me 4t by 3. Taking the LCM. And now when I multiply by minus 1 over 4. So we'll have minus 19 over 72 minus t over 3. Okay. So this is your particular integral. We combine it with the complementary function. And is there any initial value given to us? So none of the initial values are given to us. And yeah, I think there's some calculation mistake. Okay, let me just check this fraction part. You can check it using your scientific calculator, which is allowed during the exam.
So, is there any specific scientific calculator that is allowed, or we can?
Sorry?
Is there any science specific calculator that we are allowed, or we can use any calculator, scientific calculator?
Basically,
मैम
scientific
40
calculators.
अपॉन 36 आएगा.
Sorry. How much?
40 upon 36.
Okay, let me just check. I'm just using the calculator. I just opened the calculator. Okay, so I have 1 over 4. And then I have a minus 1 over 9. Because I think there's some mistake with the calculation there. Okay, whatever this thing, like I think you can manage this after this. So 4 plus 1. Okay, this is giving me a 25 over 18. And then I divide it by 4. Okay, there is some numerical mistake, some number mistake which has happened here. So any which ways, is the method clear? Your final answer here should have been, okay, your final answer here should have been negative 11 over 36. Negative 11 over 36. So there's some numerical mistake which has happened somewhere here. Okay, but is the method clear with everyone? Any difficulties in the method? How did we
मैम
apply?
38 की जगह पे 44 अपॉन 36 है.
44 upon 36 आ रहा है पक्का?
Yes मैम.
Yes, ma'am.
ओके, तो फिर सॉल्व हो गया ना, कोई प्रॉब्लम नहीं है. चलो, ओके. So yeah, this is your particular integral, and finally आपको x of t लिखना है, which will be addition of complementary function and particular integral. तो वो आपकी वैल्यू आ जाएगी c1 e raised to negative 3t, c2 e raised to t minus 11 over 36 minus t over 3. ये आपका x of t है, और उसके पहले हमने y of t ढूंढा नहीं है. ओके, y of t ढूंढना बाकी है. सो या x of t मिल गया है. अब इक्वेशन 1 या फिर इक्वेशन 2 यूज करके हमको y of t भी ढूंढना है. सो लेट्स प्रोसीड विद दैट. सो ये देखो दैट इज वाई मैक्सिमम क्वेश्चंस जो आपके आते हैं वो ऑटोनॉमस सिस्टम के आते हैं. नॉन ऑटोनॉमस यू कैन नाउ सी इट इज बिकमिंग बिगर एंड बिगर. It's a big task to solve non-autonomous. Okay, so let's solve for y also. This was x of t. Now, how do we solve for y? I'll bring back equation number 1 and 2 here and use them to find the value of y. Okay, so these are your equations 1 and 2. You already know x. We need to find the value of y. To avoid multiple calculations, what I am now going to do is I will add the two equations directly. I'll add the two equations directly. Now, what will happen on adding the two equations here is I will have a 4d applied to x. The minus 3 plus 3 gets cancelled. And the minus 2d and plus 2d gets cancelled. And I'll be left with plus 8y equals to 2 plus t. So now you can observe here that this 8y is equal to 2 plus t minus 4dx. So y is equal to 1 over 8 times 2 plus t minus 4 dx. Now what is this 4 dx is what we need to calculate. Your answer will be in t only. So 4 dx is the 4 multiplied to the derivative of x. So let's take the derivative of x. We already have the function x over here. So the first term derivative will be negative 3c1 e raised to minus 3t. Second term derivative will be c2 e raised to t as it is. Third term derivative is 0, and the last term derivative is minus 1 over 3. The derivative is with respect to t because capital D is d by dt. So let's just open the brackets and simplify this. This is going to be 1 over 4 t over 4 plus 12 c1 e raised to negative 3t, negative 4 c2 e raised to t, and plus 4 over 3. Let's just put the terms together. So I have 12 c1 e raised to negative 3t, 4 c2 e raised to t over 4, and I have a 1 by 4 plus 4 by 3. That's going to give me 3 plus 16, 19 by 12. Okay, so this is your y of t. This is your y of t. I hope how to find the question answer to the non-autonomous system is also clear with everyone. Any difficulties? Any difficulties? Yes, please. Of course, you might have to revise your, techniques of finding the particular integral and CF. Now, I want you guys to try one question on your own, okay? So that we come to know that you have understood, or if you're getting stuck, you can always ask your doubt right away. Is that fine? Okay.
Yes, yes.
Yeah. So, let's give you a question to try. Yeah. Try this. And I'm first giving you a non-autonomous. So this one was, I believe, question number 3. Okay. So coming to question number 4. Solve x dash is equal to negative x plus 2y, and y dash is equal to 4x plus y. Okay, try this. When I say x dash, it is dx by dt, and when I say y dash, it is dy by dt. Take 5 minutes, not more than that.
मैम मैम
Yes,
ये
please.
ऊपर वाला वाई टी
हम्म
का आंसर यही है.
क्या हुआ? कुछ अलग आ रहा है क्या?
यस मैम.
मैंने शायद 1/8 सब टर्म्स को नहीं लगाया है. मैंने वो मिस्टेक किया है. अगर ये 1/8 यहाँ पे भी लगाते, मैंने शायद यहीं तक लगाया था, तो ये आंसर आपका, ये बेसिकली 4 की जगह 1/2 हो जाता ना. तो यहाँ पे -3/2, नहीं +3/2 होता, and this would have been -1/2. Okay, and this eraser would work, and this would have been +1/6. And then you just calculate, this is going to give me 6 plus 4, 10/24, which is nothing but 5/12. Did you get that?
मैम T/8 स्टार्टिंग वाला 2 + T है तो T/8 होगा ना.
एक मिनट. T/8, हाँ,
यस मैम ये आंसर.
and C2 के साथ हमारा -1/2 है. Okay, the eraser is not working. I'm going to cancel and write it here. Just check if there is anything else. Is this fine?
यस मैम.
Okay, fine. So now try this question. Take not more than 5 minutes, okay? Vitamin C. করছো. आवाज बंद है. बोलो. कड़े हो जाओ, कड़े हो जाओ. हाँ चलो रे, कड़े हो जाओ. કારણ કે એક્સપાયરી ખબર નહીં કે 10 છે ને એટલે કડે हो जाए. એડા ટીકા है वो मारे भुसचे व्यो. कड़े हो. हाँ. Did you find the solutions?
Xt is equals to C1 e raised to 3t plus C2 e raised to minus 3t.
Is it plus or minus? Or okay, no problem. Constants will not make a lot of difference, whether it is plus or minus, no problem. Okay. And that's correct.
And Yt is equals to 2C1 e raised to 3t minus C2 e raised to minus 3t.
Very good, Pari. That's absolutely correct. Both the answers are correct. What about other people? Are you getting the answer? Okay. Chanchal, you got the answer?
Yes, ma'am.
Okay, great. So, do you want me to solve it, or I'll just note down the answer so that you can verify it later and we can move on to the second method? Okay. So, this was an autonomous system, and finding the answers for an autonomous system is really very easy compared to when it comes to non-autonomous system. Okay, because non-autonomous system involves finding particular integral also. Here you were just supposed to find the complementary function, or the general solution comes directly there. So I hope everyone got this answer. Any difficulties here? We'll proceed to the next method. Yes, please.
Yes, ma'am.
Okay, fine. Thank you. So the next method which we're going to go into is the matrix method. Okay, we are going to use the eigenvalues and eigenvectors over there to find the general solution. Now, one thing which we need to understand over here is, just give me 1 minute. Just give me a minute, okay? हाँ डॉक्टर. अच्छा, तो क्या बोल रहे हैं वो? हाँ, मतलब वो बोल के आए हैं. हाँ. हाँ, मतलब कुछ 500 ml इन सलाइन दिया, ऐसा कुछ तो हुआ है. हाँ. नहीं, वो क्या बोल रहा है पता है? कि इन्फेक्शन इतना फैल गया कि 2 दिन में मर जाएगी, आप लेके जाओगे, ऐसा बोल रहे. हाँ, तो फिर वैसे से बोला, और इतना पैसा भरा है ना उसने, तो वो पूछ करी और एम्पुटेशन अभी तक किया नहीं, ऐसा सब बहुत कुछ हुआ है मगजमारी. तो अभी कैसे कर सकते हैं इसको? हाँ, हाँ, हाँ. मतलब वो इधर से उधर जाने का ही नहीं हो रहा है ना, उसको वही प्रॉब्लम हो रहा है ना, फोन नंबर या कुछ मांगो ना. हाँ, जरा पूछो ना, है ना? मैं कॉल करूँ क्योंकि उसको मतलब तो पता है ना सब कुछ जो भी है. उसको बोलो उसे वैसे कॉल कर दे, आप पूरा करें कभी, है ना? हाँ, हाँ, ओके, चलो, थैंक यू. Sorry. Fine. Getting back to the matrix method, or it is also known as where we find the eigenvalues and eigenvectors. But yes, the limitation of this particular method is we can use it only when we have autonomous system. Again, not only autonomous system where there will be only constant coefficients. Okay. So how do we use this particular method? And you need to know both of them, because if the question comes, solve it by using, matrix method, or the question is saying solve it using operator method. So you should know both of these method over here. Okay. So let's understand this. The matrix method. Okay, I think the pen is taking a little time. It's also known as the eigenvalues eigenvectors method. Okay, so let's understand this method with the help of an example again. And before we start with the example here, we need to understand that we are going to convert the given system of equation into a matrix form. And we will find the eigenvalues and eigenvectors of that matrix. Okay, you have learned different methods of finding eigenvalues and eigenvectors before. And when you do this, when you find these eigenvalues and eigenvectors, you might have observed that these eigenvalues could be distinct, they could be real, equal, repeated also. Okay, so depending on the nature of the eigenvalues and eigenvectors, your solution will vary. Your solution will vary. So before we actually start, we'll just write down two rules here. Rule number one, or case number one, we can say, where the two eigenvalues, lambda 1, lambda 2, are real and distinct. Okay, in that case, your solution will be given by, the solution will be given by x of t, y of t equals to C1 times V1 e raised to lambda 1t plus C2 times V2 e raised to lambda 2t. Now, what is this V1 and V2? V1 and V2 are the eigenvectors. Okay, so for lambda 1, you will have V1 as the eigenvector. For lambda 2, you will have V2 as the eigenvector. Case number 2. Case number 2 here. We have lambda 1 is equal to lambda 2, but both are real numbers. Okay, both are real numbers. Now in this, it will be divided into two subcases. Subcase number 1, where we will get only one eigenvector. We get only one eigenvector. And second, where we get two eigenvectors. We get two linearly independent eigenvectors. So when you might have solved questions on eigenvectors, you must have come across these conditions, okay, where the eigenvector is like eigenvalue is repeated and you might have got only one eigenvector, or you might have got two linearly independent eigenvectors. So in the first case, your solution will be given by, I would denote this by capital X. Capital X is x of t and y of t equal to C1 V1 e raised to lambda 1t plus C2 V1 t plus V2 e raised to lambda 1t. Now in this case, you will have to obtain V2. Okay, V1 is the only eigenvector which we have got. Okay, V1 is the one eigenvector which we have got. And we will have to calculate V2. Okay, 1 minute, the pen is lagging. Okay. V2 is calculated by solving the equation A minus lambda I times V2 is equal to V1. Okay. And in case we get two linearly independent eigenvectors, we write the solution as x is equal to C1t V1 plus C2 V2 e raised to lambda t. Lambda is the value of lambda 1 and lambda 2, which is the same. Okay. So these are the cases which we are going to work into. Of course, there's a possibility of complex eigenvalues as well. Okay, but we'll not get into that details over here. Okay, so let's understand this with the help of a sum, of course. So let us look into this. And one thing I want you to understand is All of these questions can be solved by operator method also. So if the method name is not mentioned, whichever method you're comfortable with, do it. But if the method name is specifically mentioned, you have to follow that particular method only. Okay. So let's look at this. Okay, instead of writing consider, we'll just focus solve. The system of linear ODE y dash equal to ay, where a is equal to 1, 2, 0, negative 1, y is equal to y1 of x and y2 of x, and we have y of 0 is equal to 2 minus 1. Okay, so let's understand the system first. If I was to write it in the normal format, what is the system exactly? Let's understand that first and then we'll start solving. Okay. This system here says d of y1 by dx is equal to y1 plus 2y2 and d of y2 by dx is equal to negative y2. I hope you're understanding. How did I write this? This y dash will be the derivatives of these two terms, okay, y1 and y2 with respect to x. And the matrix A, the first row will correspond to the first equation, second row will correspond to the second equation. And it is multiplied by y. So it is something like this. What is given to you here is dy1 by dx, dy2 by dx. This is your matrix y dash equal to A over here is 1, 2, 0, minus 1 and y is y1, y2. So when you multiply the right hand side, you will get y1 plus 2y2 and negative y2, and this is equal to y1 dash, y2 dash. So by equality of matrices, I get this equation 1 and equation 2. I hope the question is now clear. The question is clear, everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
So whatever we did now, you can do it the reverse way also. So if I look at the previous questions, like if I look at this one, which you all had solved, okay, just a minute. I don't know why this drop down is here. Okay. If I look at this one, if I was to write this in the matrix form, how will I write it in the matrix form? I would say maybe capital Y dash
-1
is equal to A times capital Y, where Y is equal to X of t and Y of t. Okay, you have used a capital Y to denote X of t and Y of t. So my Y dash will be X dash and Y dash. My A over here would be -1 plus 2, 4 and 1. I hope this is clear. And no difficulties in moving from one form to another form. Are the two forms clear with everyone?
Yes,
Yes.
ma'am.
Okay, we are moving from the equation form to the matrix form, or from the matrix form to the equation form. Okay, in both the cases. So yes, that's what we have done here. Now let's see how do we use the matrix form to solve the equations. Okay. One minute, please go. Like that. Now, students, 1 minute. Parvati, बाजी को मैं ये लेक्चर कर रहा है इथे परत हे करते बघ, हं. छोटे इथे परत येतो, अधिक करायचं. अधिक करायचं. तुम्हाला नानाचा ते कबूक आहे मम्मम करायला? नाही सुमेलो, जागे तो. हाँ, गो गो. हाँ. पण नाना के जो कबूक ज्वार खाण्याला आला. आउच! भगवान ने आज है मेरा राज को बड़ा अयो तो फैक्टर नहीं चलना नाना आपकी जगह था नाना नाना जगह का नहीं सब के बच्चे खेलने में चले छोड़ो तुमको के जार करने चलते चलना मुझे बच्चे के अलग अलग सोच आज के चेंजिंग का पता है okay sorry yeah so getting back here let's learn how to solve it using the matrix form. Okay, look at the matrix A here. Can you orally tell me the eigenvalues of this matrix?
1 and minus.
Very good. It's a diagonal matrix and
1
therefore
and
the eigenvalues can be orally determined as +1 and -1. Okay, so we'll start with the eigenvalues here. Eigenvalues of A are +1 and -1. Okay, so we got lambda 1 equal to +1 and lambda 2 is equal to -1. We need to find the eigenvectors because these are distinct eigenvalues. There will be distinct eigenvectors and they'll be linearly independent, and then we'll be writing down the solution. To find the eigenvectors, we will solve the equation A minus lambda I times x is equal to 0. Okay, so for lambda equal to +1, we will have A minus I times x is equal to 0.
Your screen is lacking behind.
Sorry,
Your skin is not visible.
not visible. Okay, 1 minute.
Yes.
1 minute. It is visible to me at least.
Yes, ma'am, visible.
Visible. Okay. Okay. So yeah, bear with me. So let's use this. We'll use A minus I. So that is going to give me 0, 2, 0 minus 2 multiplied by x, which would be x1, x2 equal to 0, 0. And if I simplify this, I would get 2x1 is 0 and sorry, the first one will give me 2x2 is 0. Okay. And the second one gives me negative 2x2 is 0. So in both the cases, I'm getting x2 is 0, but there's no value of x1 which is available. So my capital X becomes x1 times 0, which I can write as 1, 0 as the eigenvector. Okay, so this is my eigenvector, say v1, which I got for lambda is equal to 1. Now for lambda is equal to -1, we will have a plus I into x is equal to 0. So this time it will be 2, 2, 0 and 0 into x1, x2, giving us 0, 0. Sorry,
Screen is not visible.
again, can everyone else see or no?
I can see your screen, but yeah, I don't know about other people.
Sorry.
Screen is visible, ma'am, but आप जो बोल रहे हो ना वो बाद में आ रहा है लिख के. It's lagging behind.
Acha. I know the pen is actually troubling me. Okay, let me again close and start again. 1 minute. It actually happens when there's a lot of annotations on the app. It starts lagging. And that is why I've stopped using Zoom because Zoom is lagging much more compared to Google Meet. Is the screen visible now?
Yes, ma'am.
Okay, and let me know if it is lagging still or it's working. So now I have 2x1 plus 2x2 is equal to 0, which means x1 plus x2 is 0, which means x1 is equal to negative x2, and that gives me capital X is equal to say 1 and minus 1, or I can call this as V2. Is this lagging or is it okay now?
Okay, ma'am.
Okay, fine. So these are distinct eigenvalues, and for distinct eigenvalues, we saw the method rule number 1. C1 V1 e raised to lambda 1t, C2 V2 e raised to lambda 2t. So that's going to be my solution. So my final solution, which is y in this case, would be C1 V1 e raised to lambda 1t, C2 V2 e raised to lambda 2t. So let's substitute C1 as it is. V1 is 1, 0. Lambda 1 was 1. So e raised to t. C2 as it is. V2 is 1 minus 1. Lambda 2 was negative 1. So if you look at this, this is C1 e raised to t with a 0. C2 e raised to negative t minus e raised to minus t. And this side it is y1 and y2. Okay, of x. Here. So this implies that y1 of x is c1 e raised to t plus c2 e raised to negative t, and y2 of t, sorry, y2 of x here is negative c2 e raised to negative t. So this is your required solution to the system. I hope the matrix method is clear. You need to find eigenvalues and eigenvectors. Now this was a diagonal matrix. You got it directly. If you don't get it directly, you will have to solve the characteristic equation. Do you know how to solve the characteristic equation, everyone?
Yes, ma'am.
Okay. So yeah, that's what is going to happen over here, and this is how you are expected to solve. So I'll give you one question to try on your own, and maybe then, yeah, we can wind up the topic after that. So okay, try this question. Okay, I think there was some initial value condition also given here. Yeah, there was an initial value condition given here. So we need to use that as well. So this is not completed. We'll first complete this. Y of 0 is 2 comma minus 1. So since y of 0 is 2 comma minus 1, this implies y1 at 0 is 2 and y2 at 0 is minus 1. So y1 at 0 is going to be c1 plus c2 is 2, and y2 at 0 will give me a negative c2 is negative 1, which implies c2 is positive 1, and that implies c1 is plus 1. So now my final answer with y1 is e raised to t plus e raised to minus t, and y2 is negative e raised to minus t. This is your answer. Okay, so don't forget the initial conditions. Let's look at the last question. The question again says solve dx by dt 2x plus 5y dy by dt x minus 2y, where capital X at 0 is plus 1 minus 1, and capital X is given as x of t, y of t. So you are expected to use the matrix method. You're expected to use the matrix method. Come on, please start solving. Will you start by expressing this in the standard form as x dash is equal to ax, where a over here would be 2, 5, 1 and minus 2. Your characteristic equation is given by a minus lambda I is equal to 0, which will turn out to be lambda square minus 9 equal to 0. So lambda would be equal to plus or minus 3. Did you get the eigenvalues? How many of you got the eigenvalues? Okay. Others are still calculating. Let's calculate the eigenvectors. A minus lambda I times x is going to be equal to 0. So lambda equal to plus 3 and lambda equal to minus 3. So when I put plus 3, it's going to be a minus 3i. And here I will have a plus 3i. So this is minus 1, 5, 1, minus 5, x1, x2. And here I would have 5, 5, 1, 1. So if I apply here R2 plus R1, and here if I apply R1 minus 5 R2. Here I would have so I get now two equations. So this implies x1 is 5x2. So if x2 is 1, my v1, which is the first eigenvector, would be 5 and 1. And this gives me x1 plus x2 is 0, which means x1 is equal to negative x2. So your v2 would be equal to negative 1 plus 1. Or you can write plus 1 minus 1, no problem. Okay, your eigenvectors can vary. Your eigenvectors can vary depending on what you take your assumption as. So we got the eigenvectors, we got the eigenvalues. Can you complete the sum with its solutions? Possible? How many of you got the eigenvalues and vectors both on your own? Okay. What about other people? Okay, that's good. Good. So you know how to now consolidate it into solution. You just have to write C1, V1 Okay, capital X over here would be C1 V1 e raised to lambda 1t, C2 V2 e raised to lambda 2t, C1 as it is, phi 1 e raised to 3t, C2 as it is, minus 1 plus 1 e raised to minus 3t. Correct, no? So we took first one as plus 3, second one minus 3. Now this gives me C1 or 5C1 e raised to 3t minus C2 e raised to minus 3t as the first one. And second one, C1 e raised to 3t plus C2 e raised to minus 3t as the second one. This is your solution for x of t, y of t. There is an initial value condition given in the question, which says x of 0 is equal to plus 1 and minus 1. We need to use that. So since x of 0 is equal to plus 1 and minus 1, when I put 0 in the first equation, I would get 5C1 minus C2. And when I put 0 in the second equation, I'll get C1 plus C2. This is equal to plus 1 and minus 1. So I can say 5C1 minus C2 is 1. And C1 plus C2 is minus 1. Adding the two equations, I'll have 6C1 is 0. So C1 is 0, which implies C2 is negative 1, which implies x of t and y of t are e raised to minus 3t and negative e raised to minus 3t. Check this. Did you understand the process? You could have definitely solved this entire question using operator method. Answer would exactly be the same. We have done it using the matrix method. Okay? If the name of the method is not mentioned in the exam, you can use any of the methods. You can use any of the methods. You can either use matrix method or you can use the operator method. Come on, any difficulties? Are the two methods clear?
Yes, ma'am.
Yes, ma'am.
Second method only applicable when you have constant coefficients and because if you have variable coefficients, you cannot form the matrix there. You cannot find the eigenvalues, you cannot find the eigenvectors. So the second method is applicable only and only when you have constant coefficients and you have autonomous system. The first method is general, which can work with autonomous, non-autonomous. It can also work with non-constant coefficients as well. But yes, your syllabus will majorly not put you into a lot of variable coefficients. It will deal with most of constant coefficients only. I'll just leave one question as a homework and then yes, we stop here. So you're expected to solve dy by dx equal to ay, where y of 0 is 2 minus 1 and y is y1, y2. A is equal to, okay, I think we did this. I think we did this. Yeah.
Yes,
Already done. Yes. Okay, fine, not an issue. So this was one of the repeat questions here. Fine. So I'll give you another one here. Try this. This does not have any initial condition, so your answers will be in C1, C2 only. Okay. So again, there is a uniqueness and existence theorem for system of equations, which says every IVT here will also have a unique solution. Okay, so that is also a part of your syllabus. And yeah, this is the sum which I'm leaving as a homework. Fine, so we'll stop here. All the very best. I will send a list of topics which you need to go through and try. Okay, is that fine?
Yes.
Ma'am, have you received any notification for the exam? This any updates?
No, I don't think so. I haven't received anything. No.
Okay.
Whatever will come, it will come on the website itself. You need to keep checking the website.
Idol website or
Yeah, mu.ac.in. There you can go on the IDOL page and you can check it out.
okay.
Okay. Right. Okay, all the very best and do your best. We have done enough matter. Go through the lecture recordings, go through the lecture notes. It should help you guys prepare for your exams. Right? All the very best. Students, you can leave now.
Thank you, ma'am.
Yeah.
Thank you.